Hey everyone, Mr. Voikin here, and this is the Unit 4 review package. These will be the questions that you're working on for day 2, the Saturday study session at home. So let's get started with lesson 4.1.1. We're doing questions number 2, 5, and 8. Okay, so let's start with question number 2. It says -8 plus t, and what we want is t to equal t. So because I have -8 there, I'm going to add 8, and now both of these sides will be equal. Question number 5. I have a -r divided by 5. Yes, that looks a little bit like an s, but it is a 5. And what I want is r equals r. So I need to get rid of that negative sign and the 5. So because it's -r divided by 5, I can just multiply by -5, and now the two sides are going to be equal. And for question number 8, we're doing sort of multi-steps here. So you can see on the first line, we want it just to equal 4x on both sides, because that equal sign tells me that it's equal. Unfortunately, I've got this +3 here, so to make it equal, I will subtract 3 from this side. Moving on to lesson 4.1.2. In the Saturday's work, we're going to be doing questions 2, 4, 9, 14, and 21. Okay, so let's get back up to the top and get into it. Question number 2. What are we doing? We're solving for the variable. So remember what we need to do here. We need to isolate that variable so it is on one side of the equal sign, and we have a number on the other side. So right now it says t minus 5 equals -21. To get rid of that -5, I'm going to add 5. Because it's equal, I need to do that to both sides. It cancels on the left, and I have t equals -16. Okay, and question number 4 says -7 equals x plus 8. I want the x to be all alone. Even though it's on the right-hand side, there's nothing wrong with that as long as it's isolated on the one side of the equal sign all by itself. It's all good. So let's subtract 8 from both sides. It cancels on the right, and it's x equals -15. If you feel more comfortable, you can rewrite that as x equals -15, moving from left to right. Okay, next question, number 9. Over here on the left, I have 7c plus 5 equals 26. The 7 is 7 times c. It's attached. The 5 is over alone on its own, so I'm going to deal with it first by subtracting 5 from both sides. But I don't have that isolated c yet. The 7 is still there, so we have 7c equals 21. And because it's 7 times c, I'm going to do the inverse operation, divide by 7. The 7's cancel out, and I have c equals 3. Okay, I'll minimize this one really quickly and circle that answer. And let's keep going. Number 14, m divided by 9 minus 5. So this one's exactly like the last one, except instead of multiplying to the variable, we are dividing to the variable. So we are going to add 5 to both sides to deal with that -5 first. So I have m divided by 9 equals 9. I'm going to multiply both sides by 9. That's going to cancel the 9's on the left, leaving me with m equals 9 times 9, which is 81. Okay, we're moving along pretty quick. Jumping down to question number 21. It says n2. That's not an n2, that's n squared. Divided by 2 equals 32. So let's deal with that denominator first, that 2 that is on the bottom of that fraction, and we're going to multiply both sides by 2. That will cancel the 2's on the left. Still leaves me with n squared equals 32 times 2, which is 64. How do I get rid of the square? Well, I square root it. And if I do it to the left side, I need to do it to the right side. And taking the square root of the square basically cancels that out, just leaving us with this n. And the square root is 64. It's a perfect square. It is 8. Okay, and I think we're moving on to the last one. Whoa, that was 21. That is the last one. Did I do 14? Yes, I did. Okay, that one's done. On to lesson 4.1.3. We have questions 2, 4, and 10 to look at, and we are solving for the variable. So if we look at question 2, inside these brackets we have the t plus 4. So the first thing I can actually do is deal with that -3 on the outside, and I can divide this whole thing by -3, and I divide the right side by -3 as well, canceling the -3's on the left, leaving me with something very simple to deal with later, a t plus 4, and -33 divided by -3 is a positive 11. Now all I have to do is subtract 4 from both sides to get rid of the 4 on the left, isolating that t, and I have t equals 11 minus 4, which is 7. Question number 4, a very common type question where I've got variables on the left and the right, and I've got these constants on the left and right, and I have coefficients attached to being multiplied to each one of these variables. The first thing we want to do is sort of move all the x's to the left and move all the constants to the right. So let's deal with this 4x that's on the right, and I'm going to minus 4x. I'm going to take those 4x's away. I need to do it on the other side as well, and that leaves me with 3x plus 6 equals -3. Let's get rid of that 6 by subtracting 6. I do it again on the other side, and I'm down to 3x equals -9. Now, because it says 3x, that's 3 times x. Divide by 3, the inverse operation. They cancel, leave me with x equals -9 divided by positive 3 is a -3. And the last one in this section is number 10. There it is. So this one says use substitution to verify if the variable is correct or incorrect. So we have our equation right here, and we're trying to see somebody did the work. Is the value of x 7? Well, remember what we're trying to do. We want the left side to equal the right side. So the right side is 39. So I just need to substitute the value, the x, with the value of 7 and do the work, do the math. And if it equals 39 on the left, then 7 is the correct value of x. If it doesn't equal 39, it is wrong. So let's start off with 5 times our variable plus 4. What is the variable? The variable is 7. What is 5 times 7? It's 35 plus 4. What is 35 plus 4? It's 39. And yes, 39 equals 39. So this answer is correct. All right, so we have lesson 4.2.1. We got 6 questions in here to work on. So the first one is question number 2, and it's saying to us, is this true or is this false? So is -4 greater than -2? Well, remember on a number line, moving to the right, the numbers are getting larger or greater, and moving to the left, the numbers are getting smaller or less. Now here is 0, and if I go backwards, it's -1, -2. So our -2 would be right in this spot right here, and going back it'd be -3 and -4. So the -4 is right here. So even though the number 4 is greater than 2, the number negative 4 is actually less than negative 2 because it's going to the left. So negative 4 is not greater than negative 2, it is less than negative 2, so this is false. Okay, and number 5, we've got a decimal and we have a fraction. So we know that 0.5 is the same as 1/2, and 1 over 4 or 1/4 is the same as 0.25. So which one of those is less? Well, would you rather have 1/2 of something or 1 of 4 of something? 1/4 of something, you'd rather have 1/2 as it is larger. So a half is greater than a quarter, not less than, as it's indicated here. So this is also false. Okay, the next section says match the graph with the letter and put it into the box that has the statement that matches the graph. So what do we have here? I've got a solid dot at 4, so that means it equals 4, but it's also going to the left, so that means it's less than and equal to. So I need to find a variable, and they seem to be using x right here, that is less than or equal to 4 in this case, and that is going to be this one right here, so this will be D. Okay, and we're looking at graph C, or the number line C. Again, I have a solid dot, so that means it's equal to 2, and so x is at least equal to 2, but it's also going to the right, so that means it's greater than 2. So I need to find x is greater than or equal to 2, and that is this one right there. And the last two questions, this time they're doing it in reverse order. They're giving us the statements and telling us to draw it onto the number line to the right. So this next one says, the first one says t equals 0. Well, if it just equals 0, then it is one solid dot right on the 0. No arrows going anywhere else. There is only one correct answer, and that is t equals 0. The next one says t does not equal negative 2. So to say a number is not included or not equal, we make an open circle. And now what you need to do is you need to do a number line going to the right, and don't forget that arrow, and a number line going to the left, don't forget the arrow. So basically it's all the numbers to the right of negative 2 and all the numbers to the left of negative 2, but it does not include negative 2. Moving along, lesson 4.2.2, we're doing questions 2, 5, and 10. So let's start off with question 2. It says solve for the inequality. So this time it says 6x does not equal 18. Well, I just keep that not equal sign in there and I treat it as a normal algebra question where I'm trying to get the x isolated on one side and numbers on the other side. So all I'm going to do is divide both sides by 6. Cancels the 6, and I have x, and I just have to make sure instead of putting equals there, I put not equal to. 18 divided by 6 is 3. Okay, moving down to question number 5. Oh, and it says, be careful, make sure you read everything. Come on, Mr. Boykin. Then graph the number on the number line. Okay, so it says x does not equal 3, so it does not equal 3. I put a circle, but it is going to be everything to the right. Do that again, everything to the right and everything to the left, and don't forget those arrowheads. Okay, now number 5 says negative t over 7 plus 4 is less than or equal to 2. So in this case, let's get rid of this 4 first by subtracting 4 from this side and subtracting 4 from the other side. That cancels the 4s on the left, but I still have this negative t over 7 is less than or equal to, nope, not 2, negative 4 plus 2 is negative 2. Now this negative sign up here on the T, it truthfully can be moved down here. It doesn't matter if it's up top or on the bottom or just in front of it like this, it still makes this term negative. So let's move it down to the bottom here. So it's T divided by negative 7. So what am I going to do? I'm going to multiply by negative 7. So if I multiply both sides by negative 7, I end up with T is greater than or equal to negative 2 times negative 7 is a positive 14. Hold on, why did that sign flip? Well, if I'm multiplying by a negative number or if I'm dividing by a negative number, then the sign that was in the original equation will flip in the final answer. So we should have an answer of T is greater than or equal to 14. And that's how you make the statement true. Now, let's just double check this by going and substituting a proper value in there. So it says T has to be greater than 14, okay? Or equal to 14. Now I can see right here that I'm going to be dividing T by 7. So I'm going to make T a multiple of 7. So let's make it 21. So is 21 greater than 14? Yes, so that is a valid number that I can use. So let's start off with negative variable divided by 7 plus 4. And that should be less than or equal to 2. That was our original equation. And that variable we said we were going to replace with the number 21. So now I have a negative 21 divided by 7 is negative 3 plus 4. What is negative 3 plus 4? It is 1, a positive 1. Is positive 1 less than or equal to 2? And yes, it is, so I know that I'm correct, therefore verifying that flipping that sign was necessary. Okay, so we're moving down to, whoa, I'm almost forgetting to graph this thing again. Come on, let's graph this. What does it say? T is greater than and equal to 14. So if it's equal to, it's going to be a solid dot. Greater than means go to the right. So I'm going to go to the right. Don't forget that arrowhead. Okay, and the last one is question number 10. And this is similar to one of our previous lessons where I'm going to use substitution to verify if the variable that was presented to us is correct. It tells me to show my work. All right, so question number 10. I've got my original equation, which is right here. This is my original equation. And the answer is, or at least the proposed answer is x is greater than or equal to negative 5. And we're saying, is this correct? Okay, so essentially what I need to do is choose a number to substitute into the x that is greater than or equal to negative 5. So on a number line, if we look at it, going to left and right, if this is sort of negative 6 and this is negative 5, negative 4, negative 3, negative 2, and so on, negative 5 is right here. And it's telling us that it's greater than negative 5. So it's moving off to the right. So it's everything way down there. Now, so I'm going to just use a positive number because up here, again, there's also 0 and 1 and 2. So I can choose basically any number to the right and including negative 5. So which one are we going to choose? I don't know. Let's try 2. Okay, so if I put 2 into the original equation, so it's negative variable plus 9 is greater than or equal to 14. So that means whatever I do on the left here, once I put a 2 in here, the math should be, the value that I get after doing the math, it should be greater than or equal to 14 if this is correct. So let's try it. What is negative 2 plus 9? It is positive 7. Is positive 7 greater than or equal to 14? No, it's not. It's actually less than. So this is incorrect. Well, we're here, the last lesson in the review package, 4.3.1, and we're working on questions 2, 5, and 8. So we're talking about, in all these questions here, the perimeter, giving it the variable p, of a rectangle, and using this formula right here, which is perimeter p equals 2 times L, the length, plus 2 times W, the width. So let's go down to question number 2 and see what we got. Well, I'm given the P is equal to 42, and I'm given that W is equal to 9. Don't forget those units of meters. And what do they want me to do? They want me to find the length L. So there's 2 ways to do this. One, I can start with the formula, which is P equals 2 times L plus 2 times W. And because I'm going to be calculating L, I would want to isolate L on its own. So I would subtract 2W from both sides, canceling it right here. And I'm just going to switch this around because I like my L to be on the left. So it's going to be 2L equals this P minus 2W. And to separate the 2 from the L, it's 2 times L. I'm going to divide by 2. I need to divide this by 2. And I end up with this equation right here, which is L equals P minus 2W divided by 2. So now that I've got this rearranged formula, I can just pop the numbers in there that I have. So L equals bracket for P minus 2 times bracket for W divided by 2. So what is P? P is 42. So we'll put it into that bracket. It's positive. And what is the W? It is 9. And so now I'm just going to slide up to here. We have 42 minus 18 divided by 2 will equal P. 42 minus 18, you need to do the work and calculate the top first. So we end up with P equals 24 divided by 2. And in this case, I end up with P equals 12. And don't forget the units, which is meters. And that is our final answer. Now, I'm going to do this another way. I'm just going to shrink this all down, move it out of the way, resize. So you don't necessarily have to do it that way. Another way is just to use the original formula and then move things around once you've sort of substituted all the values in there. So again, you'd be starting off with P equals 2L plus 2W. We know P, so we're going to say 42 equals 2 times L, which is unknown, plus 2 times our W, which is 9. So on the left, I still got 42 equals 2L plus 18. Now I basically want to isolate that L, so I'm going to subtract 18 from both sides. Cancel, and I end up with 2L on the right equals 24 on the left. Running out of space, so I'll just shrink this down again. Okay, and I'm going to divide both sides by 2 to cancel the 2 on this side. And again, I end up with L equals, and I'm going to move the L to the left side here. It's not a problem. L equals 24 divided by 2, which is 12, and don't forget the units of meters. Okay, and the second part is the exact same thing. It's just saying we got different numbers for P and for W. So I'm going to use this formula that I derived right here, which is L equals P minus 2W divided by 2. So I can just rewrite this right here. L equals P, what is it? P minus 2W divided by 2. So L is going to equal P minus 2 times W divided by 2. I'm going to substitute the values for P in there of 40, W for 6, and I'm going to do a little bit of the math here. So L is going to equal 40 minus 12 divided by 2. Let's bring it up and over. What is 40 minus 12? Well, it's 28. So L equals 28 divided by, not 12. What did I do right there? Careful. Divided by 2. And 28 divided by 2 is 14. And what are the units? cm. So that's the advantage of rearranging the formula first, is that if you have to do multiple calculations using, in this case, using P and W, it'd be really easy for me to substitute those values to calculate L. I don't need to move things around. It's just basic operational math. Okay, and I think we're down to the last one, which is question number 8. What does it say? Make X the subject of the formula. What does that mean? It means we want to isolate X. So we want this formula to say X equals something. And right now it says 7 equals something. So we need to rearrange this so X is our subject. So let's get rid of that N first by subtracting N. And if I subtract it from the left, I need to subtract it from the right. So if I have a positive N and a negative N, I've canceled out the N. So on the left, I'm left with 5x equals 7, and we're subtracting N. So N is a variable, 7 is a number. I cannot simplify that any more than that. I still have not isolated that X. I have 5 times X, so I'll divide both sides by 5. And that leaves me with, again, I'm just going to create some space. Resize. That leaves me with X is equal to 7 minus N divided by 5. That's it. That's the end of the review package. Ooh, I don't like that. I like my fancy little perfect rectangle. Bing. Done. Okay, so this is basically going to be close to the structure of the summative assessment for this unit and close to the length and number of questions. It'll vary a little bit. There might be a few different type of questions, but within your capabilities, and there might be a few less or a few more. But make sure that you can get this done in about 40 minutes and you can correctly get the answers, and you should almost know how you will perform on that final assessment. Good luck, and we'll see you in class.